Hi everyone, welcome back to my channel. Today, let's see the LeetCode problem of the day. Let us jump into the problem statement. So today problem statement is 4 devices and the range of the problem is medium. It is a medium range problem, but I will rate the question for 10. My rating is 5. Usually it is a easy problem, but they mentioned as medium. Let's see the problem statement. So given an integer array nums, they name the array as a nums. Return the sum of divisors of the integers in that array that have exactly 4 divisors. If there is no such integer in the array, return 0. Okay, then read it again. Return the sum of divisors of the integers in that array that have exactly 4 divisors. What they are asking is, they are given one array. In that array, there is few elements. They are asking the sum of the divisors of each elements if and only if each element or the element which have exactly 4 divisors, not less than 4 or greater than 4, exactly 4 divisors. This is the problem statement. What we need to take care here, we need to calculate the divisors of each element and count the number of divisors of each element and sum the number of divisors of each element as a final answer. So this is a very simple problem statement. What are the, let's see the constraints. Constraints are very important in BSA concept. See, the constraint is 1 less than or equal to nums dot length less than or equal to 10. Means the length of the array is from 1 to 10, not greater than 10. The length is from 1 to 10. And nums of the elements inside that array is less than or equal to 10. Okay, those are constraints. So first we will go through the brute force approach. The brute force approach of solving this problem is nested for loops. Okay, using enough for loops, we can solve this one, but that brute force will not satisfy the all test cases of the given problem statement. Let's see the brute force first. You understood the problem statement, right? Just we need to sum the number of divisors of each element if each number have exactly 4 divisors. That's it. Okay, this is the brute force approach which I have done initially. Okay, see, first we are considering one for loop which is used for the iteration of the array. Okay, so initially I declared one variable to hold the final answer. So I named it as an answer is equal to 0, which holds the final answer. Inside the first for loop, count is equal to 0 and one list I have declared. Why list means to store all the divisors in that list. Why count means to count the number of divisors of each element. To understood it. So the inner loop, again the inner loop I am running. Why the inner loop? The first loop will fetch one element from the array. The inner loop will define how many divisors are there for the first fetched element. So the second inner loop will check the divisors from 2 to element by 2. Why I started from 2? Because 1 is absolutely the divisor of the given element and the number itself is the divisor of the given element. So we no need to check that. We are reducing the 2 iterations here. So I am starting from 2 to half of the element. Okay, above half of the element there is no divisors. We are sure that. So to reducing the iterations to half, I am checking from 2 to n by 2, means element by 2. So this is the if condition. It checks whether j is the divisor of the first element or whatever the iterated element. If it is a divisor, it it implements or it increases the count and add the divisor in the list. If count is equal to 2, then add the sum to the final answer. Means we need to add all the divisors to the final answer. So it is why we are adding 1 and nums of I. So initially I told you 1 and the number itself are the divisors of any number. So we are externally adding the number itself and 1 to the final answer. And also the condition we are checking is count is equal to 2. Usually in the question they mentioned count is equal to 4. But we are checking count is equal to 2 because 1 and the number itself, they are excluded from the for loop. We know that 1 and number itself is the divisor of the given number. So we are checking the condition for count is equal to 2 because in this loop we are not considering 1 and the number itself. So absolutely or obviously the count will come as 2. So we are checking when count is equal to 2. So those two numbers are added externally, and the elements which contain in the list, the divisors which we added in the list, we need to iterate and add it. So one for each loop to iterate the list and add the divisors to the final answer. And finally, we will return the answer. Okay. This is the brute force approach. Here we follow step-by-step pattern, like iterating the array, the element in the first for loop, taking that and calculating the divisors and adding the divisors to the final answer. This is the brute force. It won't satisfy all test cases. If you want, I will show you. First, I will uncomment this. Go the bottom one. Okay, I will comment this. And this is the optimized solution. First, we will run the brute force solution. It passes 3 test cases. When I submit it, see, it's showing the time limit exceeded exception. Only 15 by 18 test cases passed. Because this test case has lot of numbers. See, the test case has lot of numbers, and it is running out of time. Within the time, it is not executing the test case. So it is not possible to this approach to execute all the test cases. So ultimately, we will go for the optimized version. How we can optimize? See, optimization is nothing but we need to reduce the number of iterations of an loops. So in optimized version also we are using the nested loops, but we need to reduce the number of iterations in that optimized version. Let's see how we are going to reduce that optimized iterations in the optimized implementation. As like in brute force, we declared one variable to hold the final answer, starting the first for loop which iterates the array and declaring the count and the sum. Okay. So another inner loop to iterate the divisors. See, here we are checking for the square root. See, I star I means I square less than or equal to num, I less than or equal to square root of num. Absolutely, it will give the half of the number. Okay. If num modulo I is equal to 0, I think d1 equal to I and d2 equal to num by I, because if num is divisible by I, we are sure that I is the divisor of that number. Okay. And why we are calculating d2 means, see, if a number is divisor of another number, there might be a chance the number divided by I resultant also be the divisor of that number. So we are calculating the d2 itself, here itself, to reduce the number of iterations, because we know that the number and number divided by I is the divisors of the given number. So instead of iterating to up to that number, we are iterating up to the square root of the number and calculating the d2 by I, number by I. So we will get the remaining half of the path without iterating. So we are reducing the iteration time here. And then we will increase the count and adding the sum. So here one corner case or one condition we have to take care is d1 and d2 should not be equal. If d1 and d2 are same, we are duplicating the count. You see, here there might be a chance of mismatching the answer. So make sure that d1 and d2 are different, then only the count will be increased. For d2, here we are increasing the count for d1, here we are increasing the count for d2. Here we are adding d1 in the sum, here we are adding d2 in the sum. Okay. when we need to add D2, when D1 is not equal to D2. Okay. So similarly, the condition, if count greater than 4, we need to break, because our condition is count is equal to 4, not greater than 4 or less than 4. If count greater than 4, that number in the array is not eligible for the addition of the divisors. Okay. We need to break the loop, inner loop there. If count is equal to 4, then answer plus is equal to sum and return that answer. If the count is equal to 4, see, the all storage part here will get vanished. You understood, right? All the stored answer in this part will get vanished, and the first loop will increment the number, and then again the inner loop will start execution. Once it is getting out of the loop, if this condition is not satisfied, it won't break here and it will get out of the inner for loop and check the count again outside of the loop. The final count. Here what we are doing is, instead of checking outside of the inner loop, inside the loop only we are checking. There might be a chance of count is equal to 50. If we won't place it here, we need to check after 50 iterations. Instead of that, we are checking at the 5th iteration action. So how many iterations we are reducing here? 45 iterations we are reducing. So that's why it is called the optimized version. Other than that, everything is same as per the brute force. That is, test this by executing. See, you can see the solution meets up to 97.47%. And the test cases are, all test cases got implemented. Here we are doing nothing but we are reducing the iterations. Just think like where we can reduce the iterations, which loop is running more number of times. There we need to focus on the problem solution. Your creativity should apply on that most repeating loops. Okay, that's it. And please do subscribe for my channel, because the content will get premium by video. So you will get more content. Like this is not for beginners. This is not for beginners. Those who are working already, or those who are completed BTech final year and actively preparing for the jobs and trying to practice the LeetCode, for those people it suits more. So try to share this video to your friends or your friend circle who is actively looking for the job. It will help me and encourage me to do more videos. Okay, thank you.